I probably could shout and you'd all hear me. For those of you that saw the images in the book, you may have guessed I'm a scout leader. It's not unusual for me to be talking to a group of 100 kids on a campsite who are spread over a large area, so they can hear me normally. So anyway, that's nothing to do with promises and Apex. So welcome. Thank you for coming to our talk about promises and Apex. Hopefully over the next 25 minutes, possibly slightly less, we'll be able to give you some idea of how promises can be used within Apex and how we have been able to use the promise pattern within the work that we've done at Sage. And hopefully, as I say, we'll walk through an example of what we've done, how it all works. So my name is Alan Jackson. I'm a technical architect at Sage.
Hi everybody, my name is Luciana Cavalieri. I'm a developer at Sage. Well, somebody, I think, made a promise sometimes. What happened with promises? Sometimes can commit, others not. That is not so good. Okay, this is a promise in the real life. No, we commit to do something, maybe we can do it, maybe no. If we don't do it, maybe we have some consequence. What is promises in our world, IT world? Does somebody listen JavaScript promises? Okay, we have several hands. Okay. We brought some gift that we promised to give you. So, okay, we promised at the end of the session. Okay, let's start, guys. Why do we need promises? We need promises in different scenarios. One of the moments we need promises is when we need to execute a process that will take long time, and we don't know how long it will be. Other moment can be when we have a sequence of steps. Other, and this is very interesting because was what we were handling, and was when we want to do multiple HTTP callouts. Another moment when we want to execute an assigned code, and after that code finished, we want to execute another assigned code. So, okay, this is an overview that you can have in mind if you had different situations with this. They will be really interesting for you. Okay, Alan, can you explain a little bit?
Cool, thanks, Luciana. So, the way in which I think about a promise, and certainly when we come to the Apex promises, is I promise that this method is going to return some data. Don't know when, but I just want it to return some data. When it does return that data, then I'm going to do something with it. Okay. So what we can start to do is think about, well, what method is going to get executed? Well, that's going to be my method. Okay. My method is going to be different to your method. That method is totally within the scope of you as an application developer to define what it needs to do. Okay. What data is going to get returned? Well, that can be any data. As long as we know what we're going to do with that data, we can then manage that data as it goes through a complete process. Okay. So when you think about that data that's being returned, there's nothing to stop that data being another promise. We instantiate a promise just as a piece of data. So we can start to chain together these promises, and we can start to actually create some pretty funky functionality. Okay, and that's what we've managed to do at Sage. Okay, it's worth being aware of the basic syntax of how we've defined a promise. This is our definition of a promise. We've made use of a library. You may have heard of Kevin Poorman. He did an implementation of the promise pattern. We've taken that and we've made changes to that to suit our own needs. But we have a basic promise class, and that's the one that's going to come from our library class. We're going to drive that how we want it to drive. It's just a library class, and typically we can just pretty much ignore that. The interesting stuff comes in the steps. So we're going to take that first step. We're going to do some work. And then when that comes back, we're going to do another step, and another step, and another step. We can chain together these steps as much as we like. All we're doing is, behind the scenes, is we're creating a list of those steps. It's just going to be a FIFO list. We'll just deal with them as we process them. If something goes horribly wrong, we need an error handler. And when we're done, we want a done handler. Okay? So where we get an error, processing our steps, and we'll see how this really fits into the whole process in a minute. That error handler can take decisions around based on what has actually happened. Remember, all of these classes are things that we have defined, and they're simply just inheriting an interface. And it's that interface that the base promise class is aware of, so that that's how it knows how to deal with all these individual classes. So once we've defined what the promise is, we then say go. We execute that promise. Okay? And that's where the promise then is undertaken. Okay? So within the promise, we consider it having three states. It's either pending, we haven't started it yet. Still waiting for it to go. It's either been fulfilled or it's been rejected. As I say, the main four elements within that promise framework is the class, that's in our library. Okay. The step, that's just implementing an interface. The error handler, that gets called once an exception has been raised. Okay, and we'll see where that is injected in shortly. And the done handler, which happens after everything else has been done. Okay, so if you want a reference to Kevin Poorman's implementation, that's where it is. That's where we based our implementation from. The implementation that we've got has got a few different changes in there, just simply to suit the needs that we had. Okay. So, Luciana, can you tell us about an example that we used at Sage?
Okay. This one was a difficult user case, but I will try to make it simple as possible. Okay, so our customer, we want to create a new company. To create this company, have different options. For example, can choose the country, the language, the business type. Okay, that's the easy part. And we said, okay, how we are going to organize these steps? First, we thought, could be in a package, but later update a package every time we need to update a little change. Will request a lot of effort. So we said, okay, templates. Template was the solution we found. We found the solution, but we didn't have idea how to do it. So we said, okay, template, where we are going to store the template. Finally, we found a way to do it, and we store in an outside server. So the process was the customer want to create a new company. We will need to download the template, only the templates that they need, and we need to install it. The installation will require an order, so it will be something like asynchronous. The download template we wanted to do like in a assigned way, asynchronous way. Why? Because for every company, we have now hundreds of templates. So at the same time, these hundreds of templates have different size. So how was it now? The user have already choose what he wants. We will download the template from outside server. We download the template with the promise pattern. And here was the magic thing. It's like, okay, we can do it with a promise pattern. Will it cost much less than doing in a package? And other thing we thought in that moment was, why not using batch? Yeah, but the problem with the batch was that it has not the same option to log the errors that promise offered. That we will talk a little bit more with Alan explain that. So, okay, so this was our case. And let's see some code now. The first thing we did was a helper that we receive a list of this object, the instance template list, that is only the information we need of the template that are in the server that we need to download, but not the template itself. So we will create a list of IDs so we can track and do the monitoring later if there is some error. For every template, we will here in the line 12 create a promise. And then we execute the download method, and we keep the tracking the ID to do the monitoring. Okay, let's see the execute download.
Okay, thanks, Luciana. So we can see here, this is basically a way in which we're controlling the process. as we dig down into this, we created a helper class that was going to actually generate the underlying promise, the one that we want to execute. Okay, so we can see here we've got the helper class in place. The execute download takes the information, and we're defining that promise. You'll see this is just following that same basic syntax we had before. Here we've only got the one download step because that was all that we needed in the end for the way in which we needed it to work. The promise error is there just to be able to handle what happens when it goes wrong. And we'll come into more detail on all these classes shortly. Okay. Yeah? Question?
You showed earlier the new promise can have like step 1, for example, and then another then for step 2, for example. So what is the execute at the end? What's getting executed then? Because each step is going, right? And then it's coming back, moving to the next dot.
Okay, so for those that didn't hear the question, ultimately, to paraphrase the question, what's the point of the execute when we've got the steps as well?
Right.
Yeah? Can I come to that at the end?
Yes.
And you'll see exactly how that fits into the process. Okay, cool. So this is the way in which we create the promise, and it's worth just being mindful of a couple of the limits that we have around Salesforce in the way in which we can use some of this stuff. One of the problems that we faced for Sage was the number of .thens we could do. And I'll explain that a little bit in a moment. Okay. So, what does a step look like? So this is the step that is actually going to really do the work. Okay. So we've talked about we're going to kind of do some work, and we're nearly getting to do some work. This is where the actual work happens. Okay. So we've got the downloadable step. It's just implementing an interface. I trust most people here should be used to that kind of concept. The interface is defining the resolve method, and it's that resolve method which is where we do the work. Okay. Because of the way in which this whole process is invoked, and we'll see this in a moment as we see the glue at the end of what brings it all together, but we ultimately end up with a brand new DML context when we're running this. Okay. So as Luciana has already alluded to, as we start going off to go and get our templates from our external storage, she'll be aware that'll be an HTTP callout. If we start doing DML operations, and then we need to go back out again, I'm sure most of you will have hit you can't make HTTP callouts when you've got DML operations pending. Yeah? Has anybody seen that message? Yeah? Is it a pain? Yeah? So this is a way in which we found to get around this, to be able to get it to work. Okay. So in this case, all we're doing is we're calling off again to another class to actually go and do the work, but it's living in this DML context. Okay. As we move on to the done handler, then what we want to do is, once the process has finished, what do we want to happen? As an application developer, you may just want the user to find out at some point because they go into an org and see things have changed. If that's your bag, fine. You may want to send them an email. You may want to put something in Chatter. You may want to find some other way to let users know that what's happened. Okay? And that's what the done method under the done interface allows you to do. It means you can go off and do that specific notification out that you need to do. Okay? Here we're not doing anything particularly complex because we wanted to try and just keep these slides nice and clean. When things go wrong, the error handler is going to get called once the exception has been generated. Okay, so it's actually ultimately coming out of a catch block. So we get told what the exception is. The error method, unsurprisingly, is the single method in the error interface. And it's at this point we can choose what we do. Remember, this is our code. It's your code. Based on that particular business need, what do you want it to do? So, if we're calling out to an HTTP service somewhere, how do we know it's running? Has it gone down for maintenance? Has it timed out? Has it, for some reason, just not given us the data we need? The exception's been generated. At this point, if we want to, we can re-queue that promise. We can put the system and kick it back round so that we can retry. Okay. I suspect most of you, or many of you, may be submitting self-assessments to HMRC last month. Many people do that. You ever tried ringing HMRC in January? Yeah? Have you sat on hold for an hour? Yeah? All been there. So you don't know how long these things are going to take to come back. Okay. So by having this kind of infrastructure in place, it means that we can restart the process. We can go back in at a particular point. It's up to us what we do here. Okay. So I've talked about this sort of magic bit of glue that holds everything together. This is that glue. Okay. This is the code that lives inside the promise class. It's worth being aware that the promise class itself is actually it is queuable, allows a queuable context method to be called. Okay. So what we can do is we keep re-enqueuing here. All right. So what we're doing is, as we come through that execute process, we're taking that first step. We're taking it off the front of our list. For some reason, it's called a stack there, but we're taking it off the front of our list. We execute, we resolve that particular step. Okay. The result of that step is then going to be passed on to the next step. Okay. So as long as you've got an awareness of what your steps are doing, you can pass anything between your steps. It's up to you to know what you're passing around. Okay. So we resolve this particular step. If we've got more to do, we're just going to re-enqueue. So at some point in the future, just depending on when that job comes back around, we will then do the next step. And we keep going and we keep going and we keep going. Okay, until we finish all the steps that have been added with the then method. Okay. If we've got nothing left in the stack, then we're simply just going to complete, mark the job as done, do whatever we need to do in the done handler, and it's at that point we can then exit the process. If any of these steps were to generate an exception, and we can see here the error handler being generated and being used at that point. We pass the exception on, and then, if necessary, if this wanted to re-enqueue the job, this particular execution would end, but would be able to just come back in on a new promise. Yeah, that makes sense. So the scenario we had at Sage about being able to download all the template files, bring them into the org, be able to then install them into that particular org. The challenges we faced were the fact that we'd install one template, which might then mean we need to install another template. Now that other template is going to require another call back to the storage to go and get it. So that whole HTTP callout DML pending message became the bane of our lives. Okay. I've kind of touched on some of the limit issues. The limits that we face here, if you're running a production org, this queue, this list of steps can pretty much be as long as you like. If you're in a developer org or a trial org, you've got four. You've got 4 steps plus the context you're in, because you can only go to a depth of 5 on the enqueuable jobs. Okay. There's another problem we faced, because how do we deal with that difference between a developer sitting working away, a trial org, which may be how our customer gets instantiated, or if they're already on a production org, then they can just go and do what they want because they've got the space. So it's worth just bearing that in mind. Be aware of the environment into which you are actually executing. Other things just to be mindful of is, as you start to try and re-enqueue these jobs, you can only enqueue one job from the current job. You can't enqueue 2 jobs, or it's not supported to enqueue 2 jobs from the current job. Having been thinking about this presentation, it's something I fancy going and trying, just to see what happens. If somebody says it's not supported, it normally means You could do it, but you've got no idea what will happen. So I am actually going to go and have a play with that when I get time. Okay, but it'll be interesting to see how that does work. I suspect we may get some unexpected behaviors, which is fine. That's the way it works. The other comment that it is worth making is that you can't do this in a test. So this code that you've seen today is not production code, all right? We've simplified it, we've squashed it, we've reduced it down to get it onto a screen, hopefully that we can get the idea of where it goes and what happens without having all the separate layers that you would have if you're starting to write production code. Okay, it's worth bearing in mind that that can't be run from a test. So your steps need to be executable in a test environment. We need to get that code coverage. All of those of you generating packages need to make sure you get your 75% code coverage. You know all this. Okay, so by being able to have those in helper classes, you can just execute that. Okay. I think that was it on restrictions. Okay, so hopefully we've been able to give you an overview here of how we've managed to use the promise pattern to solve the problems that we had at Sage. You guys will have different problems to those because you're writing your own applications. But for us, we had a specific need that we needed to solve, and we found through the promise pattern that we were able to solve it. Let's say Kevin does deserve a note of thanks for the work he did in putting it all together initially, and we've just simply tweaked it for our own personal needs. Okay? So, with that, thank you very much. Any questions? Yes.
You had a slide with a for loop that was creating all the promise chains. First one.
The first one?
Yes.
Yes,
Yes.
from the outside. That one, yes.
Do each of those promise chains resolve before the for loop comes back to the top again and does another promise chain?
So the way it works in practice and how we've done this, then ultimately, as soon as we execute there, that's where the promise is then instantiated and will go. At that point, we then move on. Once we've hit execute, we're then going back around and it then jumps back up through the stack. We're back here. I think the actual code we're showing here would imply that that first step gets resolved before it gets enqueued. I did realize that as I was on the train yesterday. That wasn't the intention. The intention is that it actually calls out at that point, so that first run, that first step, is executed asynchronously. So you could have all of your steps, all your promises queued before any have actually started. If you start needing to get into that logic of, I need this one to happen and that one to happen, and then I can do this one, then that's where you start building your logic in your step to say, has that one finished? Has that one finished? No. Well, in that case, I'll just requeue and we'll go back around again. Yeah? Does that make sense? Does that answer the question of the bug in the code that we've got here? Okay, sorry about that.
Is the order fixed? I mean, is the order in which I queue my promises the same as the order in which they get resolved?
So the question is, do they get resolved in the order in which they're queued? That would be Salesforce dependent. Ultimately, it depends on the... So all we're doing is we're enqueuing jobs. Are they guaranteed to be first in, first out on that queue? Ask Salesforce. Okay, because at that point, all we're saying is, here's some work, go do it. Come back when you're done. So I think practically, yes. Is that guaranteed? Don't count on it. That would be my take on it. Because obviously, you're going to, because these are all running in that background context, you may have multiple ones running together at the same time as well. So your first one might not complete until your fifth one's actually finished, just depending on the amount of work that's going on in your step. Yeah. So I would expect that to be indeterminate. Okay. Cool. Thank you. Yes.
You say there was a limit on the number of thens you
So is there a limit on the number of thens? Yes and no. It depends on the org in which you're using. If you're in a developer org or you're in a trial org, yes, because of the number of times that you're re-enqueuing within that one. So queuing from another queue, you can only go to a depth of 5 in total, just in that type of org. In a production org, go for it. See how big you can get. There's a challenge for you. Cool. Any more questions? I think we're probably going to get booted anyway. Cool. Anyway, well, thank you very much for your time.